Every single day, we look up and see it, the sky. But have you ever stopped and asked yourself, why is the sky blue? Why not green or purple, or just black like outer space? This might sound like a simple question, but the real answer takes us into the world of sunlight, the atmosphere, human vision, and even sunsets. By the end of this video, you'll see the sky in a whole new way. Let's start with sunlight. To us, sunlight looks white, but it's actually made up of all the colors of the rainbow. Each color has a different wavelength. Red has the longest wavelength. Blue and violet have shorter wavelengths. Think of wavelengths like ripples in water. Some are long and stretched out, others are short and quick. Now, as this white sunlight enters Earth's atmosphere, it collides with tiny molecules of air, and that's where the magic begins. When light hits the gas molecules in our atmosphere, it doesn't just pass straight through. Instead, it bounces, scatters, and spreads out in different directions. This process is called Rayleigh scattering, named after Rayleigh, the scientist who studied it in the 1800s. Here's the key. Longer wavelengths like red and yellow are barely scattered. They pass almost straight through. Shorter wavelengths, like blue and violet, scatter much more strongly, about 10 times more. That scattering fills the entire sky with blue light, which is why no matter where you look, the sky glows blue. But wait, violet light has even shorter wavelength than blue. Shouldn't the sky be violet? There are two reasons it's not. One, our eyes aren't great at seeing violet. Human eyes are more sensitive to blue than violet. And two, the ozone layer absorbs much of the violet light. So what's left and what's dominant is the blue light. So in a way, the sky is violet in the physics sense, but our eyes and atmosphere team up to paint it blue instead. Now, here's another question. If Earth's sky is blue, why does space look black? The answer is simple. Space has no atmosphere. Without air molecules to scatter light, the sunlight just travels in straight lines. Astronauts see the sun as blindingly bright, but the rest of the sky is pitch black. This contrast shows just how important our thin layer of atmosphere is. It literally colors our world. Okay, but what about those stunning sunsets? Why do skies suddenly turn fiery red, orange, and pink in the evening? At sunrise and sunset, sunlight has to pass through a much thicker slice of atmosphere before it reaches our eyes. By then, almost all the blue light has scattered away. What's left are the longer wavelengths, red, orange, and yellow. That's why sunsets and sunrises paint the sky in warm, dramatic colors. It's the same scattering principle, just stretched across more air. This is why the sky on Mars looks different. Thin atmosphere, mostly reddish. It's also why the sky on Earth can look whiter on hazy or polluted days. Larger particles scatter all colors more evenly, washing out the deep blue. And it's why pilots, climbers, and astronauts see the sky darken as they rise higher, less atmosphere above them to scatter light. So the next time someone asks you, why is the sky blue? You can tell them, it's because sunlight is made of many colors, and Earth's atmosphere scatters the shorter blue waves in every direction, making the entire sky glow blue. It's a perfect mix of physics, vision, and atmosphere. Science literally painting the canvas above us. If you enjoyed this explanation, make sure to hit like, subscribe to Calculated Clarity, and share this video with someone who's ever stared at the sky and wondered the same thing.